Hello guys, my name is Alapson. Welcome to this channel. This is my #1 video series on ROS. In this video, I'm going to talk about ROS basic concepts. So let's dive into the tutorial. ROS is an acronym for Robotics Operating System. ROS is not an operating system in a typical sense, but much like an operating system, it provides a means of communicating with your hardware without writing your own device drivers. ROS as a framework, it provides tools for visualization, simulation, and analysis. In a nutshell, ROS is an open source software framework for robotics development. ROS enables roboticists to divide robot software into small and standalone units that cooperate to achieve the overall goals. A typical robot is made up to sense its environment using sensors, make decisions using software, and take action using actuators. Building such a robot before the advent of ROS used to be a long and cumbersome process, as all the components had to essentially be built from scratch. So ROS simplified this process by providing powerful communication system allowing these components such as sensors, software, actuators to communicate with one another by breaking each of them down into small unit processes called nodes. A node is basically one executable that represents a program inside your ROS application. Typically, each node on the system is responsible for one small and relatively specific function of the robot's overall functionality. You can write nodes in many languages you want. Most supported ones are Python and C++. To fully understand the concept of nodes, let's look at an example of an object-following robot. For example, if you want to design an object-following robot, in ROS, we will divide it into 3 basic functionalities. Each represents a node. First, we will have a camera node, which is responsible for capturing the image from the camera. Second is the object detection node, which is responsible for processing the image and detect location of the target object from the image. And finally, motion control node, which will drive the robot toward the target object. So the question is, how are these nodes communicate and interact to achieve the overall goal? They do that via messages. So the primary mechanism that ROS nodes communicate is to send messages to one another. A message is a simple data structure comprising typed fields. To continue with our example of an object-following robot, the name of the message sent by a camera node is called image. It is sent in form of multidimensional matrix, while the object detection node sent a message as pose, which means location. It is sent as XYZ coordinates, while the motion control sent a message in form of twists. It is also sent as linear velocity XYZ and angular velocity XYZ. However, However, the nodes need a medium to send messages to one another. In ROS, nodes share data with one another by passing messages over what we call topics.
A topic is a simply named bus or channel, which you can think of as a pipe between nodes through which messages flow. In order to send a message on a topic, a node must publish to it. Likewise, to receive a message on a topic, a node must subscribe to it. In this case, as in our previous example, the topic called camera images is transporting image message from camera node to the object detection node, while position estimate topic is transporting pose message to motion control node, and so on.
So far we talked about nodes, which is a small and independent program that performs a specific task. Then I said message is information that flows from one node to another. And finally, we talk about topic, which is a channel in which message flows through. At the center of all this is ROS Master.
The ROS Master maintains record or registry of all active nodes in the system. It allows each node to discover other nodes in the system and establish lines of communication with them. In this instance, let's say we have two nodes, a camera node and an object detection node. The camera node starts by notifying the master that it wants to publish images on the topic camera images, and tell master this is my address, and master keep record of camera node's address. Now object detection nodes want to subscribe to the topic camera images to see if there's maybe some images, and tell master this is my address, and master keep records of it. Now that the topic camera images has both publisher and a subscriber, the master nodes notify camera nodes and object detection nodes about each other's existence, so that they can start transferring images to one another. Once these nodes have located each other, they communicate with each other peer-to-peer.
Okay guys, that's all for today. Thank you for watching. I will see you in the next video. Don't forget to subscribe.